Buenos Rios, getting ready for another math lesson. Go ahead and pull out your packets and get ready to take some notes. We're going to go ahead and jump into the video. Welcome to the first video in lesson 3-4. In 3-4, we're going to be focusing completely on the intercepts, yet another one of our characteristics that we're going to be discussing in Unit 3. Specifically, we're going to look at the x-intercept and the y-intercept. So we've talked about these briefly before, but we're really going to hone in and focus on them in this lesson. So an x-intercept is where the graph crosses the x-axis, and the y-intercept is where the graph crosses the y-axis. Now you can see on the right how we write x-intercepts and y-intercepts. They're always written as an ordered pair. For an x-intercept, your y value will always be 0, and the x will be the point where it crosses the x-axis. For your y-intercept, your x value will always be 0, and your y value will be where it crosses the y-axis. So let's go ahead and take a look at some examples. So for a linear function, we're going to be looking at a function that looks like this. Our x-intercept is going to be where it crosses the x-axis, so this one right here. And we're going to want to look to see what x value that crosses off at. Now it looks like on this one, their x-intercept is going to be kind of halfway in between two of our marks. So sometimes we might have to be a little bit of an estimate when we're giving our ordered pair. So if I count over, it looks like that's between 1, 2, 3, and 4. Somewhere between 3 and 4. It looks like it crosses about halfway right there. So we're going to say that the x-intercept is 3.5. That's our x value. And our y value for an x-intercept is always going to be 0 because we're not going up or down at all. Now if I look at the y-intercept, that's going to be where it crosses my y-axis. So I'm going to look to see what y value it crosses. My x value will always be 0 for a y-intercept, and this is going to cross somewhere between -1 and -2. It looks like it's going to be a little bit closer to -1 than to -2, so I'm going to estimate that that's going to be about -1.25. And there I've done it. I've given the x-intercept and the y-intercept for the first problem. Now let's look at the quadratic. We again want to look at the x-axis and the y-axis and see where it intercepts. If we look at the x-axis this time, we're going to see that it actually crosses twice. Then we're going to actually have two x-intercepts. Alright, now looking at these, it looks like that crosses at -1. So our x value for the first one will be -1. Our y value again is always going to be 0. And then over here on the second one, the x value looks like it crosses at 3, and the y value will be 0 again. Alright, then we'll go ahead and take a look at the y-axis and figure out the y-intercept. If we look to see where that point crosses, it looks like that's going to be at -3. Remember, our x value is always going to be 0. And our y value was -3. So there we've given the x-intercepts and y-intercepts for the quadratic function. And now let's take a look at the exponential function. So looking at the exponential function, if we're looking at when it crosses the x-axis, this line is actually never going to cross. We're going to hit something that's called an asymptote. We're going to take a little bit closer look at that later as to what an asymptote actually is. But for now, what we need to know is that line is never going to cross over there, and it's never going to reach the x-axis. So in this case, we're going to say that for x-intercepts, there are none. Alright, we will have a y-intercept, however, if we're looking at where it crosses the y-axis. It looks like it is going to cross right here. Our x value is going to be 0, and our y value is going to be 5. We've talked many times about there are certain patterns that you can pick up on in mathematics, and we will see some of those patterns when we're looking at x and y intercepts. For a linear function, you're always going to have one x-intercept and one y-intercept. For a quadratic function, however, there are more options. For a quadratic, you could have 0, which is going to be a quadratic that just kind of has its vertex up here and is going to be up high and never touching the x-axis. We could have 1, where it comes down and just touches once and then comes back up. And then we could have 2, like we had in our example. However, your y-intercept, we will still only ever have one y-intercept. For exponential, we could have 0 x-intercepts like we saw in our example, or we could have one that starts down here or goes down like this. that's going to have just one intercept. And our y-intercept again will always be 1. Now, one of the reasons that we always have just one y-intercept is everything that we're talking about in this unit, linear, quadratic, and exponential, are all functions. And remember, part of our early definition of what a function is that each y value can only be matched, or can only be used once. Each element in the domain can only match to one element in the range. We talked about the vertical line test. If we have more than one y-intercept, we would have 2 dots on the y-axis, and we would fail the vertical line test, so it wouldn't be a function. So since all 3 of these are functions, we know that we can only have one y-intercept, not multiples like we can with the x-intercepts. Alright, you guys go ahead and give the U-tries a try. Check your answers on the solution page, and then come back for video 2.